6 is all about quadrilaterals, but first we're going to start out a little bit more general and talk about all kinds of polygons. Specifically today we're going to be talking about angles in polygons. There's two different kinds of angles, interior and exterior angles. We're going to talk about both of them. We're going to have formulas to help us find both the sum of all of the interior or exterior and just the measurement of one, depending on how many sides your polygon has. So, as always, when we start a new unit, let's start with some vocab. The first little bit of vocab here is all about interior angles. So this whole top section of my page all talks about my interior angles. An interior angle is exactly what it sounds like. It's the angle that is inside of your shape. So in my triangle, I have 3 interior angles. Do we know what the measurement of a triangle is? Of all 3 interior angles of a triangle, it's, Casper? Perfect. One of the methods that we are going to use to figure out what is the measure of different kinds of shapes as we continue growing with more and more sides is we're going to use triangles because we know that a triangle is 180. We've hopefully hammered that fact into our brains. So if I take a look at the next shape, which is a quadrilateral, it has 4 sides, and essentially what we want to do is figure out how many triangles, non-overlapping triangles, can I split that quadrilateral into. So I'm going to start at one vertex, draw a line through my shape, and divide it into triangles. I have 2 triangles here. They don't overlap. They encompass the entire shape. 1, 2. To figure out the sum of the interior angles of a quadrilateral, I would do 2 triangles times 180 to get 360 degrees. Does that kind of make sense? This is called the seashell method because as I go and add more sides, so let's look at that pentagon, they kind of start looking like seashells. I start at one vertex, and I'm going to connect this one vertex to the opposite vertices. I can't connect it to this one right here because it would just form a straight line, and I can't connect it to that one right there. So I can't do the ones right next to it, but I can do every other vertex. So here, I get a triangle. Here, I get a triangle. Notice what I'm not doing is I'm not going in overlapping triangles. Like I wouldn't draw another triangle like that because then my triangles are overlapping. Not what I want to do. But I do split this into, I don't know why I started here, 3 triangles. So for a pentagon, I would multiply 3 times 180 to get 540. So the sum of all the measures in a pentagon is 540. Same thing with my hexagon. Again, maybe you can see it's getting more and more like a seashell as I keep going here. I can divide this hexagon into 4 different triangles. So 4 times 180 tells me that the interior angle sum of a hexagon is 720. Do we see a pattern here? Anybody recognize what the pattern here is? How do I figure out how many triangles can I get in one shape? Think about the number of sides in our shape and the number of triangles I can make. There's a pattern. Anybody see it? No? No? If I have 3 sides in my triangle, I have 1 triangle. If I have 4 sides in my quadrilateral, I have 2 triangles. If I have 5 sides, I get 3 triangles. The number of triangles that we can make, depending on how many sides we have, is always the number of sides minus 2. That is how we get this formula right here. The sum of interior angles of any polygon is always the number of sides minus 2 times 180. So there's 2 different ways that you can kind of remember how to do this. You can use that seashell method like I did up there where you're drawing out the shape, you're drawing in the triangles to figure out how many triangles, or we use this little formula which says I take n, which is the number of sides, minus 2 times 180. And that basically tells me that for any shape, I can add together all of these interior angles here, and I will get that number. So in this shape, maybe I do the seashell method. 1, 2, 3. I know there's 3 triangles. 3 minus 2, or sorry. 5 minus 2, because there's 5 sides, times 180 would give me 540. Questions there? Now, I want to take that formula and I want to rework it, because that is the sum of all of the angles on the inside. But if I just want to figure out one interior angle of a regular polygon, I need a different kind of formula. Do we remember what the word regular means? I'm talking about shapes. We talked about it with triangles a little bit. Anybody remember? That word regular means all sides and all angles are congruent. So all the sides will be the same length, all the angles will be the same measure, which makes my life a little bit easier, because if I want to figure out what one angle of a regular polygon is, I would take the sum of all of the angles, which we hopefully know from right above there is n minus 2 times 180. That's my sum. And I just divide it by however many angles I have, which is the same as however many sides I have. So to get the measurement of one angle, I take the sum, which is this guy right here, and I divide it by the number of sides or angles. Any questions on that? So 2 formulas for interior angles, except they're kind of the same formula. One is just divided by the number of sides. Let's talk about our next topic, which is the opposite. This is exterior angles. Let me change this color here. So let's talk exterior angles. We've got a different kind of formula here for exterior angles. Oh, hello. There we go. Close enough. I don't have my video pulled up. I normally have a fancy video for this. An exterior angle is what we get when we take a shape. So let's outline this shape here so that we can see it. Here's my triangle. And essentially what we did is we just extended each one of these sides to form a straight line so that we get an angle on the outside of that triangle. Okay, that's what an exterior angle is. It takes one of the sides, it extends it so that we get an angle on the outside. Let's add together these exterior angles. So here's a triangle. I want to figure out the sum of its exterior angles. So I would do 120 plus 100 plus 140. Add that all together. We get 360 here. Let's look at another shape. Here's a quadrilateral. It's got 4 sides. I'm going to do 105. 105, go away. Plus 40, plus 105, plus 110. Any guesses what this is going to get us? It's 360. Okay. What about number 3? That's a pentagon. It's got 5 sides, I think. Yep, 5 sides. I add 65 plus 98 plus 36 plus 50 plus 111. Hey, guess what? It also gets us 360. So what do we think our pattern is? Well, our pattern is that when I add up the exterior angles of any shape, no matter how many sides it has, how big or small it is always going to add up to 360. 360 is like our magic number for exterior angles. Okay, no matter what we do. Really quick before you turn over, because I know you're turning your page, I just want to add a little note on the bottom here. If I wanted to find one angle of an exterior angle, and they're all the same because it's regular, let's put that note in here. One angle, let's say one exterior angle. Angle of a regular polygon. I would take that sum, which is 360, and again, I would divide it by that number of sides. So very, very similar to what we did for our interior angle, which is where I took the sum and I divided it by n. We do the same thing for exterior. We take our sum, we divide it by n. So just a quick little reminder on there. Okay, any questions on this? Flip it over. For the most part, for these examples, we're going to talk about interior angles. So let's first focus on these first 4 questions are all about interior. So think about your interior formula. Our interior formula is the one that's a little bit more complicated. We have to do 180 times n minus 2, or n minus 2 times 180. So think about that. Find the sum of the measures of interior angles of a convex nonagon. All of the ones that we talk about in this unit are going to be convex. Remember, convex just means it's not concave. It doesn't cave in on itself. So I want to find the sum of measures of the interior angles. Those are the keywords I'm looking for. Of a nonagon. How many sides in a nonagon? Dahlia? 9. Perfect. I'm going to use my formula, or you can draw out a nonagon. I don't know why you would be crazy enough to draw out a nonagon. Maybe you really like drawing nonagons. I don't know. But I would take my formula and go 9 minus 2 times 180, which is 7 times 180, aka 1260. I don't have where are my notes? I believe it's 1260. Yes. Okay, don't remember your formula? That's okay. We can take our nonagon that I just drew, which is a little bit messy, but I can draw my nonagon and divide it into triangles. Look how many triangles I get. 1, 2, 3, 4, 5, 6, 7 triangles. 7 times 180 gets me 1260. We good on those 2 methods? All right, find the value of x using the figure. This is not a regular polygon. It does not say that all of the angles are the same, so we cannot set angles equal to each other to figure this out. The way that we're going to do it is we're going to add all of my angles together to get whatever the sum of my shape is. Now, this is a pentagon, 5 sides, right? We can count 5. So I need to figure out what's the sum, and then I need to add all those angles together to get that sum. So the sum is 5 sides minus 2, always minus 2, not 3, times 180. You don't believe me? Split it into triangles yourself. There's 1, 2, 3 triangles, which is 540. We add all those pieces together. 142 plus 2x plus 3x plus 14 plus 3x plus 14 plus 2x equals 540. I combine my like terms. And I solve. So for that one, x is 37. Questions on that? We know a sum means we add things together. So do not set things equal. Make sure we're adding things together. All right. The poles for a tent form the vertices of a regular hexagon. When the poles are properly positioned, what is the measure of the angle formed at a corner of the tent? Again, some keywords that I'm looking for. I see this is a regular hexagon. That's telling me all my angles are the same, and there are 6 of them. Then I see the measure of the angle formed at a corner. So I'm looking for one of my interior angles of this tent. So let's take a look. Maybe it helps to look at the diagram. That's terrible. I see this 6-sided shape. It's a little distorted because of the perspective, but we know that all 6 of those angles are the same. So I need to figure out what's the sum of all of them, and how am I going to find just one? Any ideas about that formula? I need to find one angle, one interior angle. Dahlia? Exactly. The top part of that fraction gives me the sum, the total of all of the angles. I divide that number by 6 because there's 6 angles. That's going to tell me that the measure of one corner of that tent, 4 times 180 over 6, is 120. Right? Yes. Questions on that? Okay, one more like interior angles. This one's a little bit different. You're going to see this come up on your math lab. This says the measure of an interior angle of a regular polygon is 135 degrees. Find the number of sides in the polygon. They love these problems, okay? We are not changing our formulas at all. We are just changing where we're going to plug stuff into our formulas. So I'm still looking for those same keywords, which are the measure of an interior angle of a regular polygon. The one angle is 135 degrees. I'm looking for the number of sides. My formula to get the measure of one angle of a regular polygon is still this one that we had on that last page, where I take the sum and I divide it by n. Okay? That's the same thing I'm doing here. Except I don't know n, so I'm just going to leave it as n. I do know that this, whatever n is, must equal 135 degrees. I didn't change my formula. I just changed where I plug stuff in. From here, what's my first step to solve? Because I feel like sometimes we get a little stuck on that. What do I do first if I want to solve this? Don't think too hard. It's algebra. Oh no, we can't get stuck here. I mean, I kind of figured we would, but I'm trying to get n to one side of my equation, right? This stuff up here is all kind of trapped, right? The top of my fraction bar is trapped. I'm just going to move that n on the bottom. The opposite of dividing by n is multiplying both sides by n, right? This is just algebra stuff. Please don't get stuck on this. We get n minus 2 times 180 equals 135n. Do we now see how we can solve this? Hopefully. We distribute. And we solve. I'm going to move 135 to the other side to get 45n equals 360, or n equals 8. Yeah. Okay, not too bad, just a little bit of algebra. If I have 8 sides, what do I call this shape? What's an 8-sided shape called? Huh? What? What's an 8-sided shape called? Oh, I'll sit here and I'll wait for you to tell me what an 8-sided shape is called. Caitlin? Thank you. Beautiful. All right, good on the interior angle stuff. Now we're going to switch to exterior angle stuff. When I'm talking about exterior angles, remember, I have a magic number. That magic number is 360. All of my exterior angles always sum to 360 no matter how many sides I have. So if I'm trying to find x in this diagram, my exterior angles are formed by taking a side and extending it. So each one of those is an exterior angle. I am going to add all of these up. And they all have to add together to make 360. I'm going to combine like terms. I believe this is 18x equals 360. I think my constants cancel out. I'm going to divide everything by 18. I'm going to get x is 20. Good on that. Last one, find the measure of each exterior angle of a regular nonagon. Important keywords here. I'm looking for each exterior angle, so just one of them, and it's regular and a nonagon. Like we said at the beginning of this page, a nonagon has 9 sides. If I want to figure out the angle of just one of those angles, the measure of just one of those angles, I take my total. I divide by the number of angles. 360 divided by 9, 40 degrees. That's it. Any questions? Fantastic.